Hey everybody, this is Erin here. Before this video kicks off, I need to address the quality, and unfortunately, the quality isn't that great. We had some streaming technical difficulties, and most of it seems to be on my end, but as I was watching this video back, trying to edit it down, I realized that, yeah, unfortunately, it's just not the highest quality, but hopefully it's not a big deal to you. My suggestion is to cue this up and listen to it like you would a podcast while you're driving to work or while you're at work or doing something else. We're not doing any kind of show and tell, so technically speaking, you don't have to see the video, but just keep that in mind that there are some video glitches and there are some audio dropouts. We couldn't avoid these issues. I still think you're going to be happy you've watched this. This is one of my favorite discussions so far. And with that said, let's go ahead and start it. Hey everybody, this is Erin from Erin's Audio Corner, and today we've got a special guest on. This is David Bosch, R&D engineer at Kef, and just I'll go ahead and throw this out there real fast that we're about 6 hours apart in time zone. There is a little bit of a delay, so when we're talking, just understand that that delay is built into the streaming platform, and that's nothing that we can control. Okay, now David, if you don't mind, maybe give us a little bit of an intro about yourself, and we'll just go from there. We'll just have an open discussion and chit chat from there.
All right. Hi, Erin. Thanks for having me here. I'm very excited to talk. I'm an R&D engineer at Kef. I've been at Kef for almost 4 years now. I started as an intern doing my master's project with them, and then I got invited to be part of the team. I mostly work with acoustics, but I also do software, digital signal processing, and all things related to active and passive speakers.
Cool. Yeah, I saw the LS60 recently announced, so that's pretty interesting. For everybody, that's watching this, I typically conduct these interviews. I don't like to call them interviews. They're just chats, and they're free flowing. But I do try to have some things to talk about along the way. And some of the questions that I've sent David over just kind of as a heads up so he would understand, or maybe get a chance to maybe think about some of these questions. And I only sent them like 30 minutes ago, I think. So it's not much of a heads up. These are all derived from questions that I have and feedback in the comments for the videos and reviews that I make. And then some of them are just a little bit of my own. And I think we're going to start with the one that I always see. And this is Doppler in regards to the moving waveguide from the UniQ design. And my stance has typically been that, as long as it's a three-way, I don't really see that being an issue. Maybe if it's a two-way and there's a lot of cone movement, then maybe. But I really wanted to point this question toward you and ask you, what's Kef's thoughts on it? Has there been any kind of internal research on it, et cetera? And yeah, that's kind of it. I'll leave it open-ended for you to take over.
Yeah, sure. Well, I've seen some discussion about Doppler in both um, research and online. I think the terms are a little bit misleading. Doppler effect. I don't think it's a thing to worry about too much in this kind of speakers. If you're talking about really large speakers like at concert levels, plane waves, it might be the case, but with hi-fi speakers at your home and small sizes, and what you should really be worrying about is intermodulation distortion, which is probably what most people. So IMD does happen when you have a larger driver running a lower frequency signal next to a smaller driver, and with coincident drivers, it is, as you know, the mid-range driver in the UniQ of back and forth. It modulates the shape of the waveguide for the wave of the tweeter coming out, and this is where you can hear. I think it's worth mentioning that in coincident drivers, if you have a normal woofer and tweeter arrangement, and they're close enough, you will get a very similar effect. And it really is a function of displacement. I mean, if your larger drive is not moving too much, displacement is low, IMD is not really audible. It's only when it's really moving a lot that it's audible, which is more of the thing with two-way speakers. Three-way speaker like R3 or reference one. The larger driver in the UniQ is a mid-range, and we cross it over before it moves too much. And only at really high levels, it's moving sort of like 2 millimeters each way. So I think at that point, you've got much bigger fish to fry than IMD.
Yeah, no, I can imagine.
Other types of distortion.
Yeah, no, and that's a good point. Is when I talk about Doppler,
that's my take on it.
Right. Yeah. And when I mention Doppler, I guess I'm talking about more about the timing, how the timing changes. But that seems to be only, based on what I understand, is if there's a lot of cone movement. So, and there is ways for me to measure that, but the problem with me measuring something like that is I really need to be outside of a room environment. And currently, even though I have a clipable near field scanner that's great for anechoic measurements, but that doesn't allow me still to do IMD anechoic measurements. So that's something different. Now, I did actually, for the heck of it, I did actually move the microphone to the near field for the reference one Meta and did some IMD measurements there. And I don't even remember, I think the drive voltages were anywhere from like 1 to 8 volts. I fixed the bass tone at 450 hertz because that's about where I think 400 or 450, somewhere in there, where the crossover for the mid range is. And then I let the tweeter sweep from, I don't even remember now, I think like 2,000 to 10,000. But I remember looking at the data and thinking, well, based on what I've seen coming from Clipple, where they say these are kind of the typical thresholds, it was well below those typical thresholds. I was tempted to post that data, but my concern with doing something like that is there doesn't really seem to be a good understanding. Maybe in the professional community, such as yourself, you and your constituents may look at that and be like, oh, I know exactly what that means. But as a reviewer who's presenting data to a lot of various people, my concern is providing something without a solid explanation. And I don't have the means or understanding to provide that solid explanation. And that's kind of why I wanted to ask you about that topic. And, is that something that internally at Kef, do y'all battle with, or do y'all feel like that's not a big deal? And that's kind of the answer I expected was with a three-way design, not so much, and maybe with a two-way design, if there's enough cone movement, but otherwise not so much.
Yeah. Yeah, I think in a nutshell, I think that you might have cone movement that is a more more in the realms of it might sound, if it's sounding too much, but if you're pushing that speaker too hard, then also you might
Okay, I was actually just writing down a note when you were saying that. So sorry. Every once in a while, just for your own knowledge, if I look down, it's not because I'm not paying attention. It's because I'm actually taking notes in real time. So, one of the questions that I didn't have on here that I meant to put on here was, so from my understanding, and correct me if I'm wrong, did you design the crossovers for the ref metas?
Yeah, a year and a half ago, Jack came to me and said, do you want to do blade and reference meta? And I was like, yes. And initially it was going to be just sort of taking the new 12th generation UniQ and adapting it to the new CPU from scratch, and also several modifications to the system, some of which are mentioned in the white paper that you might have had a look at already, and some of it to make it sound better. So yeah, it was more of a taking the systems that were already existing and adapting the new UniQs, building new crossovers and modifying the system slightly for all of the models. Reference 1, 3, 2, 4, 5, Blade 2, and Blade 1.
I really want to get my hands. I did ask y'all's, I guess, your marketing affiliate here in the U.S., Stephanie, who's been great, by the way. If Stephanie's watching this, you've been awesome. I did mention to her, hey, if you want to send a blade my way to let me test it, that'd be fine. Maybe that probably won't happen, but a guy can dream, and then I may leave the country too.
Why not? Oh,
Yeah.
keep asking, Stephanie.
Yeah.
Yeah, that'd be
Yeah.
great. That'd be really, really exciting.
Yeah. So along with the crossover design, this is a question that I had Greg Timbers on from retired from JBL a couple weeks ago, and one of the questions that I asked him, and I'm going to ask you the same thing, is his process for designing the speaker. From and especially in the crossover area for you is what's that process like? I know Kef does a lot of computer simulation and modeling and things like that. How do you balance the measurement aspect versus the listening? Because and then I guess that also bleeds into particular voicing. Is there a particular voice? Maybe that's a separate question. But yeah, how do you kind of balance the listening aspect versus the measurement and modeling aspect when you come to designing a speaker?
Yeah, well, the actual process of designing a speaker depends on the kind of speaker, and depends if you're doing it from scratch. Like with reference metal, we already had systems that existed, and we modified them and put new drivers into them. But if you design a speaker from scratch with perhaps the constraints, like if you need to fulfill a product brief that requires a certain size of speaker, certain output, certain frequency response, certain characteristics of the sound, and then you try to come up with an acoustic brief or an acoustic proposal to try to fulfill these product brief, right? And then you do it with perhaps a combination of the current technologies that you can offer and that you can put into a product, and technologies that you might be working on or you might want to be working on. So that you're then left with the task to develop these technologies and these product through a period of time, and say you begin with some simulation, some lump parameter modeling as to the acoustic system, the response of the bass, how high, well, how low it can go, how hot it can get, and so on. Then you might start thinking about the drivers is your first step. We do spend most of the time designing the drivers. Then in parallel, we might start thinking about the cabinets. And once we have all of the prototypes, these can be both virtual prototypes that we simulate on FEM or BEM and look at the response and try to optimize them, or physical prototypes, or both. Once we have something that we think is going to work, we then build something for sure. Then we measure it, and then we build. Well, you were measuring about how we tie measurements, listening, and simulation. It's sort of like a triangle that we do in a reiteration process. Once we have a prototype, well, we measure it, then we take that data and build up all of the crossover. Then we prototype that, listen to it. Then if at that moment it sounds great or it doesn't sound great, then we come back to our model, try to see if we need to investigate further and find out if there's something else going on. And then we go to, you might have a nice balanced speaker in your model, but you might not be looking at distortion, you might not be looking at how hot things get, or a ton of maybe a resonance that's not coming across in your measurements you're listening to, that your hearing is bugging you and it's messing up with the balance that you're trying to make. And then you look into that more closely through all the measurements. So maybe measurements with microphone, you can do near field, so you can point a laser at different panels or parts of the speaker and try to find if the resonance might be coming through a part of the speaker, and so on. Yeah, and as for voicing, or balancing, I guess our process most times the same in that I think we follow sound, right? So every time we balance a new speaker, we're not starting completely from scratch. We sort of know what's going to work well. But like in the process, I think since LS50 Meta, wireless to, and then Blade and reference Meta, we've really been looking more into how the speaker. We did that obviously before, but we've been more closely looking to that, which I suppose you'll find very interesting. And certainly, I would say, looking at the relationship between off-axis, what's its power response, what is maybe several average curves that you can calculate from your measurements, and how it sounds is something we do take into account for the balance. At the end of the day, our aim is the same. We want to come up with a speaker that sounds neutral, or whatever neutral means to most of us, and balance. That is that nothing doesn't sound unnatural, and that most music reproduced into it through it sounds natural and neutral. Yeah.
Yeah. No.
Does that answer your question?
Yeah. No. That's a good answer. That's kind of what I was curious about. So neutral is really the target there. I mean, people have different perceptions of how one brand sounds over another. I do know that some brands target a certain response, however nonlinear it may be on and off axis. My experience with Kef has been that at least since like I started testing speakers in the last decade or so, is that linearity is of prime form. And I will go ahead and mention this since you discussed this earlier, is the white paper. I applaud you guys for putting that out there so freely. I mean, I'm sure there's some information that maybe you're keeping inside, right? But the fact that you release as much as you do is really cool for me. And I think just maybe speaking on some of the people who are interested in what I do, I think they're also very appreciative of it, and it makes it a lot easier to decide if that's something that they want to buy. For example, the LS60 wireless, you guys have the white paper for that. And the first thing I jumped to was the contour plot. And I saw that and I was like, oh my Lord, that's really good. So I am excited about having the opportunity to hear those sometime and look pretty sweet.
Well, yeah, no, hopefully you will. You will soon. Yeah, well, the idea of the white papers, we've been made LS50, the original one, but they got a little bit more serious since reference 2014. The whole point is trying to show and explain as much, or as best as we can, what we did, mostly in the engineering, why we're doing them the way we do, and then what are the results, right? So, for example, in the last white papers, the reason why we're showing spinoramas and contour plots is because these tools are perhaps easier to read by and customers for sure, and that they can, through these plots, understand how our technologies result in something at least you can measure and show on a paper, right? Obviously, I mean, the test would be to listen to them. And yeah, I mean, I suppose another aspect of it is just telling a story, so that you understand why we're doing why we're doing things the way we're doing it, why we think stereophonic reproduction is a good means to produce your favorite music, and how speakers with a smooth directivity and a wide frequency response and way to do stereo. Yeah, and they make a good beat, I think.
Yeah. Yeah. No, I agree. I mean, that seems to me like the logical way to go about things. Then let people, if they want to, then they can change the sound, with EQ or tonal balance and stuff like that. Um, I think that actually kind of ties into one of the questions I have here, which is
That
with,
oh,
sorry.
maybe I no, I was just gonna add that. Yeah, you're completely right. Like in active speakers, for instance, we can offer the additional level of personalization. So if you have a room that's smaller, that's bigger, if you need to place your speakers closer to the wall, or if you have too much absorption and you can't do anything about it, and you don't have to have that in your amplifier on your EQ on your own, right? So yeah, that's something really attractive about active speakers.
Yeah, no, well, and that's a really good point too. Is the rooms being different, not even just your personal preference, but how the room drives what you're hearing in the seat. How close the speakers are to the wall or how far away, et cetera. Um, yeah, so that kind of leads into the question I have, and this is going to be my last question, but it's not going to be anymore because I have a couple other ones. But I think this is a good transition into, you know, I don't know how to word this in the right way, but having listened to the reference one Meta, and this isn't me just um, being super nice or kissing your butt. That's a great sounding speaker, right? And what I think is, how does Kef top that? Like, what do you see? What's your end goal? Because to me, I think as an engineer, I'd probably say, okay, that's good. We're good. Now we can just change the cabinets, make it go lower, or maybe give it a little bit more output, right? But then that's an engineering feat in itself. So I'm curious, what would you see as an engineer as maybe the ultimate pinnacle of, okay, I've reached what I wanted to reach. Now I'm done. And do you think that's actually ever achievable in the real world?
Yeah, well, there's several aspects. I think it's quite obvious. Several aspects that in which the speakers that we make or the speakers that I make are. I mean, the obvious one is if you just follow the design principles that we have, that is um, close to like point source with a control directivity, and this directivity smoothly tapers into high frequency, and it tends to be wide at high frequency. That response is as smooth as possible, both in frequency and in space, and reach high dynamics without compression, without distortion, without power compression. Um, Certainly, distortion is a thing that we still are working on constantly to try to reduce in for every kind of different driver, LF drivers, for MF drivers, and for HF drivers. And for sure, the aspect of it being a product that can lead, it can be small enough for it to fit wherever it needs to fit, and that its form and function works well in your life, that it connects well to your media, to your devices, and so on. Other aspects that we are improving on, right? And that there's still so much to do there. But I think, at least from the point of view of acoustics, I think the next leap forward, I would say, most tempting is for sure seeing where active speakers can, or how far we can take active speakers, right? And how far we can take DSP and distortion control and just the how do you say the processing of the signal in such a way that it improves your experience of the speaker in any space that you choose to put this speaker on, and that it can improved perception of your music, right? Or your improved experience of your music. I mean, if you want something specific, distortion is one thing that we're really looking into. Active speakers and all the related technologies are very, very exciting, and a lot is going to happen next. And we'll see also, it depends on how the market leads that, and because active speakers have been around for decades, but it is only recently with streaming and more DSP processing capabilities at a low cost that we're really seeing active speakers being proposed in much smaller formats that actually work in people's lives, that actually solve the problem of enjoying your music in.
Yeah. Well, and I think also the fact that the LS60, you guys has HDMI in it. I think speakers that have HDMI eARC into them are making that a lot more feasible, a lot more useful, I guess, for the average consumer. So I think that's cool too, because then it brings hi-fi into the average consumer world. Now, the LS60, I mean, they're not cheap, but that technology will eventually trickle down into products that will be more feasible. I would expect, in the long run for an average consumer, somebody who's looking in the more budget-friendly range, right?
Yeah, definitely. I mean, I think the way we see things forward is always not always trickle down. We can trickle up. I mean, for example, we launched the metamaterial absorption technology with LS50 Meta, and
Yeah.
then saw a way to put this into blade and ref. I think it's just a matter of finding a. I mean, this is a little bit beyond what I do, but finding a perhaps a market case or business case that will allow us to offer a product that actually makes sense and that can do it. I'm sure that we will be able to include all of these technology that we develop into as many products as we can at an affordable cost for as many people as we can, right?
Yeah, no, that absolutely makes sense to me. Well, and this is another question I was going to ask you about, and it ties right in here too. Is based on your experience, and I know this is probably out of your area a little bit, but just based on your experience, would you say that your designs are engineering led, just by ingenuity, or would you say that they're marketing led, or would you say it's just a mixture of both, and it kind of depends?
Um, I think it's mostly engineer led. So historically, Kef has been R&D led. The founder had this very clear new geometries, new ways to make speakers, and still here in Maidstone, we are the way we transform new ideas into products and then design new technologies that result in better sounding products. But obviously, I mean, marketing has a very important part in doing these. Like we work together with our colleagues from product management and marketing and industrial design. And yeah, at the end of the day, we have to make products that answer to everyone that makes sense, right? I think yeah, we're pretty much there from the point of view of engineering. We don't compromise too much, which I really like personally, working R&D. So we
Right.
do
Yeah.
get away with a lot of our ideas, and they seem to work well. So we seem to be able to put them into the speakers at the end of the day, which is great.
Yeah. Yeah. No. Well, and that's kind of what I get from your company. You know that you guys are very much engineering led. Where, you know, some of my experience with previous manufacturers, it seems some of those engineers have told me that a lot of their designs are based on marketing. When you become so large, then marketing starts being the ones to drive the designs, and they have to design something within a box.
Mm.
But every once in a while, their engineers will have the opportunity to flex their prowess and their engineering ability and design something that's really cool. And usually that winds up being something like the flagship models or something like that. You know, that's a little bit more costly.
Well, I mean, there are cases, of course, and they're just as valuable when someone will come to us and say, "Can you make a speaker with these characteristics?" And it's a challenge, right? And that is a great challenge to have when someone asks you to do something that you can't do and do it yet, but we're looking into it. And sometimes we come up with something. I don't know. LE60 wireless is a perfect example. How do you make a speaker that's so slim with the technology that you have? And we had to come up with something, and that's where Unicore came out, right? And then yeah, some other speakers are more like led by engineering and turn out to be good sellers, like LS50, the original one. Um, it wasn't supposed to be, I think, what it ended up being, which is, but it's good, right? I think it's valuable if everyone just comes up with a challenge that answers the market's requirement for better performing speakers and selling more functional speakers, uh, or other audio solutions, and that we can take that on as a challenge to develop technology.
Yeah, that makes sense. Okay, so here's a very easy one for you, or this may be tough for you. What's your favorite Kef speaker?
All right. Oh well, now because I've made several of them, I think my baby will always be LS50 Meta because that was the first like important speaker. I don't know if you can see, but there's a pair of them here, and it's now become sort of like my personal reference to have at home. Um, Apart from that, I really like them all. Reference one, the original reference one before I made the Meta. Uh, I had it for a year and a half in my previous home, and I really grew up to, and it sound. I think part of that trickled down into how I decided to go about tackling the rest of the meta speakers. Yeah, I mean, I have to choose small speakers because here in England you have a big house. Or I don't have a big house, so fits here without me having to move out of my own house. And also that has a relatively decent amount of bass extension as well. Um, and yeah, I think, well, that's my long answer to your question. The LS50 Meta, definitely. I
Okay,
have
all right. I was
a
just
connection
curious. You
to
know,
it.
I as we said earlier, that the bleed looks pretty darn awesome. I would like to play around with that, but I was curious. And but you bring a good point too about, you know, size of people's homes, because, you know, in the forums and things like that,
Yeah.
people will make fun of small speakers, or they'll, you know, do the inverse of that and talk about speakers being too large. But that's the cool thing about the hobby, you know, is that as a consumer, you have choices. You know, so if you have a smaller home, you've got smaller speakers to choose from, and the technology is being pushed to where the smaller speakers can sound maybe not better than, but in some cases maybe as good as some of the larger speakers actually, with active designs, the bass output at least moderate levels for some of these smaller speakers are better than floor standing tower speakers. You know, again, at reasonable levels before the limiter, you know, would have to start kicking in and control the excursion.
Yeah, exactly. I mean, this has always been what sells speakers everywhere in the world, and some markets will tend to have big houses with drywall uh, rooms, or leaky rooms. And here in Europe, there's more brick houses, certainly in the UK. So if you need to put a small speaker too close to the wall, to some extent take that into account, or offer a range of speakers that can sort of cover most people's needs and most people's user case. So precisely, active speakers are very exciting. Well, I mean, one of the reasons they're very exciting is because you can control the signal separately, or you can control the signal in such a way that the physics of the speaker is not what response you want to achieve. And as long as you have driver displacement, for the case of the bass extension, as long as you have driver displacement and amplifier power to do that, then there's nothing stopping you. You're not limited by the fundamental resonance of the drivers in the cabinets, and you don't end up needing giant cabinets to have that bass that you want with low distortion.
Yeah, yeah, that's very true. Okay, so depth in soundstage. I actually add this into my notes. You may have seen this and maybe wondering what is he talking about. So
Yes,
this
I
is
saw that.
this is something that I constantly comment on with I'll just coincident drivers in general. It seems that they have really good depth of soundstage, and the sound field is more three-dimensional than typical conventional designs like a dome
Mhm.
tweeter or a waveguide or something, where those, to me at least, this is just my personal opinion, they typically sound more boxed in, I guess, like rectangular. Like if you had to draw a line around the sound field, you could, you could just draw a box around the sound field. But with the coincident drivers, such as the ones that you guys make, they don't have that. And I've
Mhm.
said that for a long, long time. And others, will kind of echo my sentiments. I'm curious what you guys think about that, if that's one thing that you notice, and if you are able to attribute it to necessarily the timing or the vertical directivity matching so well with the horizontal. I mean, what's that about?
Well, like if you put in your email, it says depth. Is this my imagination? I would say yes, partly, but that's not a bad thing. Um, so your brain takes all the cues, an image or a sense, to make sense of what's going on in front of you, right? So if you're listening to the sound of the voice, your brain will try to recreate in your mind some of that voice so that it makes sense to you, right? And the thing with not only, I mean, it's coincident drivers, but also directivity matched, so that the tweeter is inside a waveguide, and then that waveguide um, restricts the directivity of the tweeter so that you can match it with the directivity of the mid-range at a certain frequency, and you can do this matching almost seamlessly. Those two things together is what makes a coincident driver like the UniQ be so good to give you enough cues to recreate that image in front of you. It comes out of the speaker in all directions, is um, progressively tapering, or is smoothly, or similarly, I don't know what adjective to come up with, but say progressively taper. If you're close to an axis or within 20, 30 degrees of axis, 20 degrees of axis, then the speaker will be as bright as it gets, right? Then as you get off axis, you won't get any points in space as you move around, where you will stop experiencing positive frequency response then, right? And then when you're sitting down in a room, you're getting sound from the speakers, but also sound from every other direction due to the coming from all directions carry the cues, both in terms of frequency and time, that will help your brain recreate this image. For example, you've seen people talk about the height of the soundstage, and then you wonder, how can the height of the soundstage be more than where the tweeters are? But then if you've got a ceiling that's reflective, it can certainly be, because you will get some sound coming back to you from the ceiling. And that might shift that image of the person or the instrument that you're listening to a little bit up. And then so it works the same way with depth, right? And so it's a matter of frequency response of all the different reflections coming back to you, their phase as well, and then your brain making sense of that. So Coincident driver takes pretty much care of these on its own, drastically, when you move around or when you get reflections from the walls, and also from the phase line between the sound of both drivers, right? Because they're in the same point or close to the same point in space. And yeah.
So it's part my imagination and it's part not my imagination.
Well, that's a good thing. Your imagination is the one that creates this virtual soundstage in front of you and makes you make sense of what's in the recording, right?
Right. Yeah. So maybe switching gears a little bit, but kind of in the same vein. Two questions in one. Is Kef going to abandon the coincident driver design and go to a standard two-way design where we have a waveguide? Probably not ever, right? But more so, and that's kind of supposed to be a joke. More so, what are the challenges that you face with a coincident design? Because there's not a lot of companies doing it, and I think that speaks to the complexity of the design more than a preference in design.
Yeah. Well, to answer your first question's last joke, I don't think we'll ever. I suppose if we find a better way to go about the same design criteria or goals that we have for a speaker to perform, then for sure, well, I mean, we'll be happy to change over, right? For now, the UniQ and the, how you call it, single apparent source, like wrapping the LF drivers around the UniQ, seems to work really well. So if we can stick to that and then improve on that, I mean, that's pretty much what we've been doing for quite a bit now, right? I suppose you could say the last generation of UniQs work really, really well were since the first Blade, in which you had already aluminium diff and dome. You had a really, really low distortion motor for both, and set flex around, that surrounding wave from the tweeter. The tangerine waveguide in front of the tweeter that makes sort of like transforms the pistonic motion from the tweeter diaphragm into more like a spherical pulsating source. And all of those put together make make what we would call the modern UniQ. And the challenges are a lot, I suppose. I mean, one of the reasons I suppose not many other manufacturers are doing coincident drivers. Some are, and some are not doing a bad job at it. But I mean, the obvious one is we're putting a very high performance, low distortion tweeter right in the middle of the mid range. You've got the two motors linear at the same time you're making them efficient, and you need space for both diaphragms to radiate to go on the back. But we used to have an absorber before and then a waveguide, right? And for these waveguide to be there and to be as big as you can, you have to push the mid-range motor outside, and that has its own complications. It's much like a packaging challenge more than anything, in which packaging takes into account the electromagnetics, the distortion coming from this, and the mechanics for sure. So the vibration transferred from the tweet to the mid-range and vice versa, and then any acoustical interaction between both. One, for instance, is the ring out of the mid-range to move. We didn't used to have an absorber in there, so you would get a bit of a resonance from it, and then you get some glitches in the response of the tweeter. And then we did like an acoustic damper or an acoustic absorber that we call the tweeter captor. It takes a while to design this thing, so I guess it's just a matter of how quick you can fix the many challenges that come with designing a coincident driver. But I think we're at a point at which we've come through most of them very well. I mean, we really have a very high performing little driver in several iterations, of course, and it just makes sense to put the tweeter inside the mid range, importantly, because you can match the directivity of both, and if you can do that, then you can ensure that you can't really tell when the output of the mid range blends into the output of the tweeter. It'll be like, yeah, there's someone right in front of me. Right? I think it works really well, and that's why.
Okay. Fair enough. Yeah, I definitely put you on the spot with that one. That was one of those. I wrote something down when you mentioned something. I was like, let me ask this. Okay, so okay. Here's another question then, and this is one I gave you a heads up on. The radiation pattern for these for the UniQ is in my experience, based on measurements, typically about plus or minus 50 degrees in the front, and that could, depending on how you draw. Like I'm talking about like maybe a negative 3 dB point. So that's kind of about the waveguide or the radiation pattern seems to be. A hair flying in front of me. That's what happens when you have multiple dogs. So anyway, yeah, back to the question was, do you target that specific angle or whatever angle it is, if it's not plus or minus 50, if it's 55 or 60 or 40, whatever, do you target that angle for any specific reason? And, that's really, I guess, just the question. Why not wider? Why not more narrow? Why what you have?
I'm going to have to give you just a partial answer. So I'm not exactly sure if we target a specific angle. I think what we're trying to do, or what Jack mostly has been trying to do since at least 2006, is try to come up with the widest dispersion possible that will work with a decent sized frequency driver that can move linearly. So you sort of have to work backwards. You start with a radiating area that you might need from both drivers to give you the certain SPL that you need for a given, for a realistic excursion. Then from that, if you're curious, there's a paper from head of group research. He made a paper in 2006 for the original Muon, in which he studied the shape, the optimal shape that he had to come up between the optimal shape for the tweeter diaphragm and the optimal shape for the waveguide right in front of it that would result in the smoothest response possible in all directions, right? So this came about from having non-spherical tweeters. We had elliptical tweeters before because they're much stiffer, but they break up at a lower frequency, right? And we had like exponential horns, and that didn't really work because it created a lot of resonances in the mouth, in the throat of the horn. That would result in quite a heavy ripple outside of it. So he went about and tried to optimize through FEM the radius of both the tweeter shape and the waveguide, and also the shape of the tweeter, and decided that if it was shaped like a sphere or like a nest in a conical waveguide, and then he decided to flare this conical waveguide out into the baffle in such a way that it resulted in the least ripple possible. So you can see that already that's a sort of compromise, right? You start with need for them to radiate what you need them to radiate, and then work out the geometry of the tweeter, its waveguide, and then the mid-range working as a flat horn. And then you sort of will be your directivity angle at the crossover between mid-range and tweeter. And then at high frequencies, it's mostly just the tweeter starting to beam, right, to become more directional. And for that, you put a phase plug in front. You definitely make it wider again, right? And then you end up with this sort of like constant directivity region above 2-3 kilohertz. So that's why I say it's like partly not a very good answer, because it's not a target per se, but it's a result from a series of design decisions. And but then, on the other hand, you have other drivers like the 4-inch UniQ in the LS60 wireless, or the smaller, the 4.5-inch UniQ in the LSX, because they are smaller drivers. The MF will start being more directional at a higher frequency.
Mm-hmm.
And the tweeter will also be will be more directional at a higher frequency, right? So you definitely have some room to change that angle, to make that angle a little bit different. And we certainly do when we're designing the profiles for both for the tweeter waveguide, right? And we end up with slightly different. If we can target the widest directivity possible, that is smooth. But this is mega important. That is as smooth as possible. That seems perfectly. And we obviously designed a crossover in such a way that this is true. Then it's going to result in the best sound. It depends a lot on the room the speaker will be put on, right, and where you're sitting.
Right.
So you might find that with a very absorptive room, a very wide directivity speaker might perform better because you don't have cues from the sidewalls, right?
Right. Well, and part of the reason I was curious about that is because I recently tested a speaker, a really nice speaker, and I tested the version 1 of it a couple years ago. This is a different brand, which I don't want to mention right now. And it had a wide radiation pattern of about plus or minus, I said about plus or minus 90, but it was probably closer to plus or minus 80, I guess. And I loved it at the time. And then as I started testing other speakers and things like that, I tested very narrow, very, nothing quite as wide, but, everything in between. And so I recently tested their V2 and I thought I was really going to love it as well. But what I found was that it was almost too wide for my home theater room because the soundstage was diffuse. It wasn't as precise as some of the other speakers I've listened. So that's part of me as a listener, kind of having a change of experience over time. But also, thinking to myself, well, when I carried them downstairs, I didn't quite have that problem because my living room is a totally different environment. And that made me think, when companies come up with the designs, how much of that design is built into or built toward and maybe an intended environment, or just trying to strike a balance between different rooms, because you don't know what room it's going to end up in, and you definitely don't want to say, all right, only use this speaker in this room, because then you're not going to sell any of them, right? So that's kind of where that question was coming from. I was curious if there's, if you strike a median somewhere in between there, or I think what your answer though is really good, because it sounds like, and when I've tried to DIY speakers, you start from the top and you work your way down. Where does the tweeter beam? Where does the mid frequency beam or the mid range beam? And where does the woofer start to beam? And you try to figure that out, place them on the baffle and work from there. So I really like that answer that you just gave. That's really cool. That's cool to have that insight.
Oh, well, okay, good.
All right. Let's see here. I really only got one other question for you, I think, because we're running about an hour, and I really just don't want to take too much of your time on this nice Monday that we have here. And by the way, this is Memorial Day for us in the United States, so I don't do this for a job. I'm actually off work today, and I'm still working for my channel. But this one is, I'd be curious to know, some of the reasons I like, having these chats is because I like providing people with an insight into the audio field, because I'm way past the ability to switch over and do audio as a career. But my hope is that there's enough young people out there that are kind of on the fence of, what do I want to do in life? And maybe one or two of them will see this and realize, oh, I can do audio as a career. So from that perspective, I'm curious about, a couple things. One is, what led you into this field? But then two is, maybe what's your favorite part about your job?
Okay. Well, actually, I mean, I started, like, me and my colleagues actually all have sort of like the same background in terms of, we all came to these through, like, as a hobby. Around when I was 11, I started getting really into speakers, like obsessively. And both my grandpa and my dad really fueled that obsession to a degree. They gave me speakers, they bought me drivers, and they both had also similar experiences when they were younger. So I had a few years in my adolescence in which I had a lot of freedom to play around, to read about these, and I also always knew I wanted to do engineering, because I didn't think that, only being a hobby was enough. I wanted to understand it. I wanted to be able to use maths to try to model it, and then to make my own designs, right? And it wasn't really until I made my master's that I studied acoustical engineering and digital signal processing. Well, that's not entirely true. I had done that before. But I would say, yeah, and for my colleagues, it's similar. We all sort of approached these initially as a hobby obsession, and then it became UK. There are a lot of speaker manufacturers, so you can instead choose from if there are job opportunities. There's others in Denmark and Finland and so on, and the US as well. So if anyone comes from those countries, for sure, there's lots of places to go. Even if you don't, if you're like I'm originally from Mexico, and there's not many, they weren't taking any jobs. So even if people come from there, I would recommend, if you want to study it first informally as a hobby, and then resources today. Because I mean, plenty of books, and there's so much content online that you can learn a lot about it. And surely, if you want to formalize it with studying acoustics, that is one way to go into the loudspeaker world. And if you're not interested in loudspeaker design, I think it's only getting more interesting as the years go by, right? Because our own team now is comprised of more electronic engineers, more software engineers that are just as crazy about speakers, but that look into the deep ends of some of the things that us acoustics guys are not so good at. And that will become more important certainly in the next few years.
Cool. All right. So, what's your favorite part about your job?
Yeah, sorry, I didn't answer that.
Sorry.
I mean, it just is so such an experience when you can sit down and listen to something that you've worked on and that you can enjoy your music on. I suppose just like you, when you sit down and listen to your music, you're transported to some other place, some other time, and that to me is worth it all. And to be honest as well, I mean, just the day-to-day of like following a scientific method to try to understand things, and trying to come up with ways of doing things. Like it really puts your imagination to work.
Yeah.
And I think that, I mean, I couldn't ask for a better job, to be honest, because you do need to get creative. There's always a challenge.
Yeah. So it's not a job. It's kind of an evolution of your hobby, right?
Yeah. I did, with lots of maths.
Yeah. Math is not my forte, but yeah. So my background is engineering. I wanted to be an Imagineer for Disney, but that wound up not panning out for a couple different reasons. But
Really?
yeah, it's funny. I always loved Disney World
Mhm.
growing up, and I wanted to be an artist for them. But then, as I grew up, it changed over to engineering. So that's why I went to school, was for aerospace engineering, because I wanted to help design roller coasters. And then I had the
Yeah.
opportunity to work there, but it was just not a good situation. It wouldn't have been paying well, and so I decided to forego that opportunity, and I stayed in my area, and I'm doing other things. But I love doing speaker stuff as a
Yeah.
hobby, and getting to chat with folks such as yourself, to have that enlightenment, and to help educate not just me as somebody who's trying to provide information to everybody else, but you can talk to people directly about what it is you do, how you design speakers, and all the little intricate details that go along with it. So I certainly appreciate you joining me today, and answer some of these questions off the cuff. I put you on the spot on a couple of them, so hope you don't feel like I grilled you too hard, but I think it
Yeah.
was fun, man. I had a good time.
Yeah, no, I love talking about speakers, and I mean, I'm surprised that you call it you call this just a hobby. I mean, you have a full-blown YouTube channel that is very professional, and you're putting out some of the most interesting reviews, and you have a clip-on near-field scanner, and are actually putting out useful data that we can look at. So I would consider calling that something more than a hobby.
Yeah, maybe it's somewhere in between. It's not. I don't think it would ever pay the bills. I just don't see that ever happening. But yeah, maybe it's not a hobby anymore. It's a full blown passion. It's a passion project. I eat, sleep, and breathe this stuff, but I also really enjoy my day job too. So That's the good thing. I get to flex my brain at my day job and work with good people. Yeah, exactly. Yeah, I can come home and just not worry about speakers, or I can not worry about my day job and switch them out. Yeah. Well, cool, man. Well, all right. Well, we will end this chat. Once again, thank you.
No, thanks for having me. Thanks
Yeah, man. Well,
maybe we can
maybe we can do this again sometime, because I have other questions, but I decided to stop asking you at some point. So I don't want to drive you nuts. You're gonna be like, what in the world?
I wouldn't mind it.
Yeah. Well, we will definitely try to do that again sometime. So.
No, I really wouldn't mind if you want to do it again, for sure. I'll try to do my best to answer them.
Okay. Well, cool. No, all right. Well, I'm gonna end this stream now, and we will talk to everybody else later.
All right. Thanks a lot, Erin.
All right. Bye.